So this game that we have here about how much warning do we get at the source or where the tributaries for the mainstream is, as opposed to how much warning do we get at the outlet, or say perhaps a base level, maybe it's like a reservoir of a dam, is very important to determine whether or not we're going to get flooding. So taking measurements at A of how much precipitation we are indeed getting from the tributaries on a constant basis and how much water is being discharged at B is very, very important. So, for example, here in Lucky Dam Peak, at the dam itself, they have to do this number games all the time. They have to see how much water they're receiving in the tributaries that are going to feed later on onto the dam or onto the reservoir, to see how much water they're going to be able to let through the dam and how much water has to be retained for further use for agricultural practices, right? So that balance is a hard balance to know, and it is very important that these numbers are kept straight. So I don't think this is any surprise, but we're going to cover linkages with other natural hazards with flooding. So we have things such as, or flooding can result for things such as hurricanes, earthquakes, or landslides. And that's no surprise, right? At least the hurricanes part should be pretty straightforward for most of you. And then in the earthquakes case, the most likely scenario in which you would get flooding would be actually from tsunamis. So we have covered the earthquakes part and tsunamis already, so I'm not going to go in depth about it. And then the landslides, how you would get flooding from the landslides themselves is you are moving so much sediment, and we're going to cover that next week, but you're moving so much sediment from one place of the mountain to the other that the sediment might actually change the path of the streams nearby themselves. And with the landslides, a lot of innate moisture from the soils may actually be carried along as well. So if, for example, in a landslide, there is a change in the path of the stream and there is subsequent, erosion of the sediments that happen and fell at the landslide, then that path that now changed is going to carry a bunch of sediments with it and redeposit them elsewhere, and perhaps making flooding at that specific new area. So again, that is how some of these other natural hazards are linked to flooding, or how flooding can occur due to these natural hazards. So before we go into the warning and evacuation and whatnot, we're going to talk about the natural service functions of flooding themselves. So as some of you may know, floodplains are actually very fertile lands. So if you think about it, in a flood, most of the material or of the water that is, covering the floodplain is going to be slow moving. So since it's going to be slow moving, it's not going to be able to carry very large sediments. So most of the sediments that the floodplain, is filled with are going to be silts and sand and clays. So silts and sands and clays are all very good soils for, agriculture. So overall, the floodplain tends to be a very good place to grow in. And farmers are, in fact, they know that, and they expose themselves to flooding on a constant basis. So on an average, I think it's every 2.2 or 2.5 years, every river, on an average in the world, every river is going to overflow its banks. So it's a very constant rate for flooding and, potential for flooding of the floodplain itself. But again, it is worth it because the sediments that are deposited, and along with the sediments that are deposited, also the very nutrient-rich particles. So those particles are obtained from, organics that have been carried with the water and the sediment from above, and also from the dissolved load. So remember that the dissolved load has a bunch of different ions, different anions and cations that, if deposited where there's other anions and cations, can react to give very nice enriched nutrients for vegetation to grow in. So that is one of the natural service functions from this flooding themselves to the floodplain. So again, the sediments that they carry along with, and also the nutrient-rich particles. Another natural service function from the flooding could be restoring of aquatic ecosystems. So for example, in the from the Colorado River, from one of the dams, they noticed that after they put, I forgot which dam, I'm sorry, but they noticed that after they put the dam, the aquatic life was lowering. They were getting less and less numbers for the amount of fish below the dam. And that's partly because the overall course of the channel was, smaller now. There were no longer these flooding events that could occur every 10 or every 100 years or however long. And so with the flooding also came sediments. So if you think about it, when you have a greater amount of water coming through and sediment coming and being transported with that water, that sediment settles at some point, and it settles at points where there's less energy. When it settles, it creates kind of like habitats for different aquatic life to reside in. So many of these sandbars, for example, that were formed in braided channels are actually part of the ecosystems of much of the aquatic life that we see. So if you now have a dam and are no longer having much of a seasonal change in that stream that used to be braided before, then you're no longer going to have those bars in which the fish used to live. So now in that specific dam, every now and then, every 3 or 4 years, or however much they view is responsible, they'll let the river pretty much flood a little bit, not enough to make it dangerous to society and communities, but enough for sediment to be transported and deposited for aquatic life to be restored. So another natural service function that flooding can have is the redistribution of the sediment itself. So you're seeing here the Mississippi River Delta and deltas, as there have been changes throughout them, as you can see here on the right image. So you see that the sediment has, through this river and through the different courses that it's taking and the flooding events that it have passed, the river itself has changed the location for its delta many times in the past, thousands and thousands of years. Now, so as an example, we have on the left-hand side one picture and one prediction, if you would. So in 2010, this is how the delta currently looks like over here, and how all the sediments that are on the floodplain of the Mississippi River look like. And then because of all the damming that we have done to the Mississippi River upstream, the 2100, so the 2100 year prediction for how that will look will be this way. So you see that a lot of that sediment that is kind of swampy currently is no longer going to be there, and the vegetation that occupies or is within that sediment that is still within that swampy terrain is no longer going to be there, because it's no longer going to receive those nutrients that come with the flooding and the sediment events. So that is another natural service function, the sediment redistribution and the nutrient redistribution, with the path of the streams changing all the time. So human interaction with these natural services that are provided by the floods. So as we have seen in the past few slides, the floodplain itself provides a lot of natural services, and not just to the environment, but also to us as humans, if we look at it on a secondary kind of effect perspective. So because it provides that sediment-rich, nutrient-rich place, we are able to settle there and grow our crops, for example, because it provides good ecosystems for our aquatic life, we are able to get fish. So there are many effects that flooding has on humans that are good. Another effect is that floodplains, for the most part, are pretty flat, so we are able to settle in the floodplains, and be able to construct and build our infrastructure and build our culture. However, we as humans do not conserve this nice dynamic equilibrium where the flooding benefits us and we let the flooding to occur. We don't like that. We don't want flooding to occur ever and still get the benefits from the flooding. So that is a problem, and we are trying to work on it, but overall we should on a basis be letting things to get flooded. But of course that is very hard to do with the amount of people and the amount of money that it costs to repair this. So there has to be an equilibrium. We have not yet come to get it, but we are on our way. We as humans are changing the equilibrium. We are no longer in this dynamic equilibrium that we should be in, but by, for example, using the floodplains as farmlands, or maybe deforesting the floodplain itself, if there had been any vegetation on it and we removed it by placing infrastructure, we are taking us out of this equilibrium. So that is not good. One of the examples, as you see down here, is that this river was initially blue, or clear, greenish, bluish, and now you see it is completely red and full of sediments. So because we have used the farm so much in the floodplain, the land so much in the floodplain for farming, a lot of the sediments that occurred due to the tilling of the land are now being transported in the water of the river and are now traveling as suspended load in that water. So that means that we are causing the erosion, and then later on there's a bunch more deposition of these sediments further downstream. This is another example on the right image of that transportation of the eroded sediments from farming. I believe that I am correct by saying that I read this last year when I was teaching Geology 101 in the book that they had, that it is predicted that before humans, just by the transportation of rivers into the ocean, there was about 9 billion tons of sediment being transported into the oceans every day or every year, I can't remember. But now that number is to 27 billion tons. So we have, increased that amount by a threefold, if you would, given the practices that we have of the land. So that is a lot of extra sediment that is being taken away from the land, transported into our systems, and then later on deposited in the ocean or elsewhere in the land. So along those lines, when we do this, when there is further deposition of these eroded sediments, we may be actually changing the overall longitudinal profile of our stream. So here's an example. We could change it for making higher gradients, all throughout the stream profile. But we could also, change it so that it's steeper over here, shallower, steeper. It depends on which specific place you're at. Sorry, that's my dog. She's dreaming. Okay. And then this is just kind of like a cross-sectional example of what things look like now with the human interaction in mind. So this dotted line over here is the original bank prior to agriculture. So that is how deep the stream used to look like. And now due to agriculture and all the eroded sediment that is now carried by the stream, there has been this amount of deposition to it. So you see that easily this is what, 2.5 meters of deposition at the stream bed, and a fair amount on the sides too. So obviously this water that used to travel over here is now traveling much higher and perhaps is going to flood more easily every time now.